Okay, in this video, we will continue on the series for creating the game Don't Eat the Yellow Snow, and this is in the Lua language using Love2D as the game library. So let's just show where we ended off with in the last video. So I'm just going to run this is the actual code that we just ended off with in the last video. So I'm going to run it with love dot. And we have an image that opens. It has a title, it says Don't Eat the Yellow Snow up here. The background is being drawn. It's 800 by 600, and we can close it with escape. Okay. Before we get going, let me just say that if you want to follow along with this, you can go to github.com, programming rainbow, and the repository is called Yellow Snow Lua Love2D. So in the last video, we cloned this repository, but you can just grab the URL up here. You can clone it, and we will be continuing on with the code. So this code that you see here is the actual completed game, but we in the last video deleted that code and we built all the files from scratch. So we're going to continue on with what we have there, and the code, the final version of the code, will be found in video 2. You just want to see the end product for this video, because this is video number 2. In this video, what we're going to be doing is we're going to create a player class, and we're going to instance an object of the player class. So in Lua, the way we do classes is we have a prototype. We basically have a table that can have data, can have methods on it, or functions, however you want to call it. And we can use that as a prototype. We're not going to actually use the player, what I'm going to call the player class, the main player table that we're creating. We're not going to use it directly ever. We're going to make an instance of it. And for this, we're only going to ever have one instance because we have one player, but we're going to do the exact same thing in the next video for the flakes, and we can make as many flakes as we want. So it's going to carry over. I just kind of want to show how this works real quick. So I'm just going to pull up another terminal and go into the Lua interactive mode. If I have a table in Lua, I can just make a table, and these are going to be global, because if I try to do local in the Lua interactive mode, it won't work correctly. So I'm going to use a mix of, if you know the different casing, the way I'm going to create the style of this is anytime I'm having something that I believe is a class for me, I'm going to use Pascal case. If I have something that is a function or a table, I'll use camel case. And if it's just the name of an atomic type, like a number, a string, something like that, a very simple data, I'm going to use snake case. Just kind of letting you know that up front. There's no strict rules on how to do this. This is just what I'm going to do. So in my head, anytime I'm making something that's going to look like a class, I'm going to use camel casing, but it's Pascal casing. It's going to start with a capital letter. Okay, so I'll just make one called my class. This is just to show how this works. And it's just going to be a table. And I'm going to add a function to this class, so it'll be method on the class. And I'll have it something like say my name or say name. So I'll say function, and this is going to be a function that's inside of the class. So I'm going to say my class. If I need access to this class itself, I could use colon. If I don't, I can use dot. I'm just going to use colon for this example. We have my class, and the name of this function is going to be called say name. So we have the say name. I'm not going to pass anything into it. And all this is going to do is it's going to print, we'll say my class. So this is a function that just prints my class. And I'll put end on this. I know this is in interactive mode, but this seems the easiest way for me to explain what's happening here. So right now, if I were to say if I use it directly, and I say name, it says my class. So that's very simple. It's basically we just put a method in this table, and I can call it. That's not really working as a class, but what if we wanted to use this as a class? So we want to make another object, another table, and we want it to get access to what we've made in this one. Let's put some data in the class too, so I can say, we'll just put a number in here. I'll just say it equals 5. Okay, so now we can have this. If I just type in, because this is interactive mode, you know, the number's 5. Now I'm going to act like I'm making an object, which would be an instance of this class. It's still another table, but I'll just call it my object. So we got my object. Okay, so this object can't really do anything. If I say my object, say name, it's not going to work. It's going to, you know, it has no idea what I'm talking about. Just making sure the rest still works. Say my name. What I want to do is I want to inherit from my class and my object. So we do this by, what's basically happening here is when I call this method, when I call this method right here, my object, say my name, what's happening is this is looking in this table to see if there is a method or if there's a function inside this table called say my name or say name. And so it's looking in the index. It's saying in this table, in the index of this table, is there a function called say name? And there's not. So it says, you know, this method doesn't exist. So what we can do is we can actually tell it if it cannot find it in this object to then look into another table. So if it can't find it, if it's indexing this table and it can't find say name, and when it doesn't find it in this table, I can tell it to then look into another table. And what that other table will be my class. So the way we do this is we can say set meta table, and you can set all different things with meta table. The only thing that we're interested in this video series is the index. Basically, if it can't find it in the table that I'm in, I want it to look in another table. So the very first thing we do is we're going to put, I'm setting the meta table on my object. So that's the very first parameter I need to pass into this set meta table function. So it's going to be my object, and I put a comma, and now we're setting a meta table. So here's the table, and the only attribute of this table that we're setting is the index. And the way it works is this is underscore underscore index, and then we can tell it to equal something. And it's very simple. Basically, I'm saying if it can't find it in the index, it's going to then look in meta table index, which is actually going to be equal to my class. So if I set that, now if I do on my object, if I say name, now it says my class. And if I want the number, the number's 5. So that's great. What happens if we change the number? So if I say my number equals 6, now did it change the number of the original class? I can print it out my number. So let's change this to my class and see if it's 6 or 5. And it's still 5. So this allows me to inherit functions and data, or methods, whatever word you want to use. We can get the methods and we can get the data that we put on in a table as a class, and then make objects of it, instances of it, that are going to inherit from it. So this is can be pretty nice if we're later on when we're making flakes, we need to make 20 flakes or 30 flakes. We don't have to, you know, make the same thing over and over again. And just to show how this is working, I'm going to make a new object. So I'll call it my object 2. Okay. So we got this new object now, and I want to get the meta table from this object. So I'm going to say get meta table, and I'm going to pass in my object 2. Now my object 2 doesn't have a meta table. I haven't set one yet. So what's it going to do? It's set to nil. So there's nothing going on there. Okay. But let's look at what it is for my object. Okay. So this table, it says it's a table and there's an address. So let's look at the address of my class. Now I can tell you right away before I type it in, it's not going to be the same, but we will see that it's in a minute, it will be the same. So my class, Now it has a different address. So this is the address of the actual table, my class. Now it doesn't match the table of the meta table for my object. That's because we're not matching on the meta table, we're matching on the index of the meta table. So if I go dot underscore underscore index, now we see that this number here for the index is the exact same address of my class. So basically, I have to use this method or function get meta table on my object. But when I actually look at the index inside the meta table, that index is actually a table too, and it is my class table. So again, the first thing that happens when you try to retrieve data or call a method from a table, the very first thing it does is sees, is it in this table that you're calling it from directly? And if it cannot find it in that table, then it says, do you have a meta table set up? If you have a meta table, I'm going to look in the index of that meta table and see if it's there. So I hope that's explaining what's happening. That's just the way that we're basically going to make a table with our data and our methods in it, and then we're going to use that as a prototype. We're not going to use it directly like we did with the game object. Instead, we're going to tell it, we're going to have a method, a new method on it that is going to generate more tables that use the meta table of the original class. I don't want to get too sidetracked here, but that's just kind of what we're doing there. So I'm going to close this off and get out of this Lua interactive mode. Okay, so what we're going to do here is we're going to make a new file, and it's going to be called player.lua. I'm going to close this bottom one first. So here's player.lua. We'll go inside here. So what we want to do is we want to make a table, and I'm going to give it a capital name, just like I did with game. Anything that I'm kind of like class, I'm going to give it a capital letter name, or even Pascal case, but for this, it's just going to be one word. So I'm going to make this local, and it's going to be player. And then we're going to just return this. What we need to do is we need to make this so that we can generate these instances. So I'm going to put a method in here, and I'm just going to call it new. And this is going to be my instance, my constructor. So function player, and I'm going to use the colon, and I'm going to say new. And we will pass something in, but for just now, I'm going to leave that empty. So what I'm going to do in here is I'm going to create a new table. So I'm going to call it new player. Now I'm using camel case on this one, so I would use, this is Pascal case. If I were to say player class or something like that, it would all be capitalized. This one's camel case, so that's what I'm going to do for the instances or method calls. I'm going to use camel case. Again, however you want to do it, it doesn't really matter. So I'm making this new table. Now we can set any kind of information we want to put in this new table, but at the end of it, what we want to do is we want to set the meta table. So I'm going to say set meta table. I need it to be this new player. That's what we're setting the meta table on. We want it to be set to player, right? So in here, we're going to have that underscore underscore index equals. Now I don't need to type player because we've used colon right here, so I can just type self. Okay, that self refers to player right here, not this new player. Since the colon is implicitly passing in self here as player, we have access to it. So I'm going to use the self here. So basically I'm saying set the meta table for new player for this new player table. And I'm setting the index specifically to player. So when that has been set, the rest of this function is just going to return new player. So it's very simple. Basically, we got a new table. We're setting the meta table for that new table, and we're returning it. And this is going to be how we generate new players. I'm going to come out of here just for a minute. What I want to do is I want an image for this player. And the image is over here called player image. And I'm going to load it in game, just like I loaded the background image. So I'm going to go into game. And I'm going to do the exact same thing, except I'm going to call it player image. Now, we could tell it to load inside the player class and all that stuff, but because this is a simple game, I'm going to have everything that's loading any resources is going to happen inside of the game object. So I'm keeping all of it here, but I'm going to pass the image in to the constructor method that makes the new player. So I'm going to say self. That self just refers to game. This is going inside a game. And we're going to call it player image. And this is going to be the same, love.graphics, new image, images, and it's player.png. Okay, so this is going to load our image up. So we have this image called player image right here. And then we want to make an instance of the player. So we already have this, we already have enough to basically make an instance, and it's returning it right here. So if I go down here, I'm going to put it below the loading of the images, and I'm going to call this create player object. I put objects, but it's just an object. And all we need to do, so I want this player, this new player instance of the player class, I want it to be also held inside of game. Everything game is holding everything for me. So the player is actually going to be instanced inside of a game as well. So that's going to be self player. So that means inside of the game table, there is now going to be an instance called player. And we get this new player by calling the new method on the capital player. So I got player : new. And it's going to complain because I haven't required player. So up here at the top, above where we make the table, I'm just going to make local player, just like we did in the main module where we required game. I'm going to require in here, I'm going to require player. So local player equals require, and the module name is just player. Okay, so that will require this player file to be loaded, and we already know when we load it, it's creating this table and it's returning the table. So this player table being returned is the player table right here. And so when we call down here, we call player new, it's going to create a new object of that's being on the new method right here. It's going to create that new table and return that new table. And now that new table is being stored right here in self player. But I really want to do is pass in the image. Well, let's just save it this far and see what's happening. Because I am going to be passing the image that we just loaded, but I just want to see everything working first without it erroring. This is really doing nothing. It's just turning back an empty table that has a meta table set to another empty table. So there's nothing amazing happening right here. It's just, we're just setting up the plumbing of all this. Nothing new is happening here. So I'm just going to run this, make sure I haven't made any mistakes yet. No mistakes have been made yet. That's nice. So what I really want to do is I want in the game, we've loaded this image. I want to pass this image in to the new method because I want to be able to get the width and height and move this image around on the screen. So, and I want player to be able to draw its own image. So the image is loaded here, but the address of it we're going to pass into here. So this will be self player image right here. And so we've set it like that. We need to go into player and we need to kind of deal with some stuff here. So I'm going to be using this underscore. So I want this image to be held here. I want this data to be private. Now in Lua, you can't actually make it private, but the convention is to use an underscore in front of the name, just a single underscore, to kind of show the programmer or anybody who's reading it that it's meant to be private. So there's no actual security in the language making it private, but the convention is just to use an underscore. So I'm going to do that. So I'm going to say new player dot underscore image, and I'm going to be doing with this with everything. This means if I ever try to call player directly from outside of this, I'm never going to use the name of the object in underscore. If I do that anywhere, I know I'm already doing something wrong because it's meant to be private. It's meant to only be used inside of this file. And I'm going to have this equal image. And the image is going to be the image that is being passed in. So here in game, when we're calling the new method, we're passing in self.playerImage right here, this image that was loaded, we're passing it in. So in here, I'm giving it just the name image. That's this name right here. So this new player, I'm getting a new bit of information held in this table, which is just another instance of the address to the image. But I'm giving it the underscore. I'm telling myself, I'm not going to be calling this directly anywhere. The only time I'm ever going to be doing anything with underscore image, it should say self on it. If it doesn't say self, if it says the name, I've already messed up because this is meant to be private to this class or the instance of it. Okay, so we have the image now. So now this table has something in it. It's an image. But what I really want is I want the width and the height of the image. I want to get the dimensions of the image. So we need to look at the documentation. Okay, so I'm just an image, and it gives me all the methods of image. So we used this before to look at how to load a new image. But what I want is I want to get dimensions. So when we have this image loaded, whatever the variable name is that is holding the image, if we use that variable name and then colon and get dimensions, if I click on this one, this is what it's going to return. So imagine this texture right here is just the name of whatever I've given the image name. And texture is a superclass of the image. So it has information about it. We can still call this method. We can call this getDimensions method on whatever image we've loaded. So imagine that this is the name of the image right here. This is the method we're calling on the image, and it's returning a width and a height. Okay, so that helps us get the dimensions of whatever image we've just loaded. So if I copy this, and I have the image now here, the image name is not texture. It is actually, we can just use image from up here. It's going to be the same. This right here is the exact same as this. So I could have written this whole thing out right here, or I could just take in the image itself. So image, get dimensions, and it's going to return a width and height. Now I don't want them to be called width and height. I want them to be called underscore width and underscore height. And also, they're not being held in player. They need to be held in new player. So everything that happens in this constructor here, I always need to write new player every time, because the table I'm in is actually player, not new player. So if I use self, it will be in player, not new player. So right here, I need to say new player dot, and I'll put underscore. Again, that's because I don't want this accessed anywhere else outside this table. Inside of this class, I'm going to be using these. So if I ever need to access this outside of here, I will have a getter method that does it. So it can't change these variables outside of here. That's just kind of for security. Like the security is kind of, it's not really there. It doesn't really exist. This underscore thing is a convention, but I know while I'm programming, I've made a mistake if I'm ever accessing anything that is underscore without saying self. but we can't use any of that self right now because we're creating the new player right now. We're not in it yet. Okay, so this is going to give us our width and our height. And I also want to know on the screen where to put this. I want to know the X location. So if I have my whole screen, if I divide my screen into two, I have the center of the screen, which is great. But then if my image is, say, 400 pixels, well, the left side of the image will be in the center of the screen, and then 400 pixels over will be the right. So what I really need is I need to divide the screen in two, and then I need to subtract half of the width of the image. So what I can do is I can just take the screen, subtract the width, the whole width, and that answer there, I can divide that by 2, and that will tell me where the left side of my image needs to be. So that's what I'm going to do. So I'm going to say new player X. Again, I use the underscore, equals. And now again, I want the width of the whole screen of my playable game screen. And I want subtracted from it the width of the player image. And then I want to divide that remaining bit by 2, and that will be where the left side of my image needs to be drawn on the screen. So I'm going to use parentheses here, and to get the width of the game, it's just love.graphics.getWidth. And this is getting the width of the game itself. So if we go into here into graphics, here it is, love.graphics.getWidth, gets the width in pixels of the window. So this is the game window. And I'm going to subtract from that new player dot width. Now I'm going to divide this whole thing by 2. And that's going to give me exactly where the left side of this image needs. So images in games are usually drawn as the origin being the top left corner of the image. So we're not drawing it from the center of the image, we're drawing it from the top left corner of the image. So I need to find out where the left side needs to be to draw the image in the center of the screen. So that's what this whole thing is doing. That's just going to make my initial X position be where my player gets drawn in the center of the screen. Okay, so that is the entire method. That's everything that we're going to do to create this player. To draw it, let's go down to drawing this. So I'm going to say function player colon draw. And what we used before, right here, this love.draw. So this is how we did it before. We need to use our own image now. So we're going to use this self underscore image. Now we can use self now for all of these. It's only in this constructor here that we needed to use the new player, new player, new player. So here, for the class itself, we're always going to say whatever the image that was set, that's the one we're going to use. And it's the underscore image. It's this guy right here. This is the whatever the name of this object being passed in is going to be self. So let's see if we can just set it up. So we have the player being required. We're creating an instance of the player. We're passing in the image to it. And down here in the game draw, we're drawing the background of the screen. Now it goes back to front. So it draws the background first, and then what's below that is going to be drawn on top of it. So we're going to say to draw the player. So to draw the player, we just need to go self.player. That's this right here, self.player, and draw. And that basically is this right here. We're inheriting this player draw method in the new player, which is called in game, which is called player. And it's being held inside the game object, so it's self.player. Okay, so we got self.player draw, and that should mean the player should draw itself. But let's just look what it looks like. It just drew it in the top left-hand corner of the screen. So we did set where the X should be, but we didn't tell the draw method to actually use that X. So that X is actually not being used yet. So let's go into look at the draw a little bit closer. The first one is the X position right here. So we have the image that we're drawing. It just says drawable, but that's the image. That would be self._image. And then this is going to be our X position. So right now it's set to 0. That's why it was in the top left-hand corner, because we didn't set it to anything. And then that's going to be our Y position. And then R is going to be the orientation. So we're not going to do anything with that in this game. So we're going to put that as 0, because I do want to use, since I want to use more things, I want to use these two as well. If you're not using anything, it goes from left to right. So if I don't need anything, I just have the picture and I skip all of this. But if I want to use the Y coordinates, I need to also fill in the X coordinates. So I need Y, X, and drawable. But since I want to use these two over here, I need to also fill in the orientation in radians. Even though I'm not using it, I'm going to fill it in, so it's going to be 0. And what I want to get access to is the scale factor for the X and the Y. The reason why I want to get at this is because I want to be able to flip the image. To be able to flip it, I can say the scale is -1. If I say the scale is 1, the image draws correctly of whatever size the original image was. But if I say -1, it's going to draw it backwards. So if I want it to be, say if I make the X -1, it's going to draw by the X-axis backwards, but the Y-axis will still be correct. So I want all of these to be used basically. So we have X, Y, R, and then SX, that's scale X and scale Y. And again, the reason why I want this is because I want to be able to flip the snowman, the image left to right. So we have the image right here. Sorry, it's in player. We have the image right here. And the next thing is going to be the X, which we already know what the X is, because it's going to be self._x, because we've created it here. We don't have anything for the Y. We can actually just leave it off if we just want to see what X will do and see if that actually draws where we want. And that fixed it. So the snowman is now in the center of the screen on the X-axis. Now the Y-axis, we don't want to use the center. We want them sitting on the snow. And just by using trial and error, I found out what that number is. So what I'm going to do is I'm going to create a constant. I'm going to create a constant, and the constant, when I create it, I'm going to put it at the very top. This is the constant for the Y, so I'll say local, and I'm going to give it all capital letters because it's a constant. And again, this is convention. This is not locking it in as a constant. There is no actual constant in Love2D. So I'm going to call it player Y, and I'm going to say that equals. And again, this was just trial and error. I just had to find out what number kind of worked, and it is 378. And this will just get them down there. So I'm using that, and what I'm going to do is I'm going to use the constant directly here. But just know that this is convention. It's not really a constant. So if your code changes this number anywhere, it will get changed. Okay, so I'm going to put the other ones in. I'm going to put the 0 for the radians, and then I'm going to put 1 and 1, meaning the scale of the X and scale of the Y are both normal. So this should all draw correctly now. However, the Y now, the snowman should be on the snow. And there he is, he's on the snow. That's great. So let's look at how can we get input so we can move this guy around. Right here, keyboard. We can use love.keyboard.isDown. It's just checking if a key is in the down state. Not if you pressed it down, but if you're holding it down, if it's just in a down state. And it's very simple. This is just going to be returning a Boolean. It's just returning a Boolean is down. So I don't know why they've held it in a variable here. This is returning a Boolean. So this is going to be true or false. If I put something in here like the left arrow key, if I just put left in here, this is going to return false if left is not being pressed and true if it is being pressed. So this is being used as a Boolean here. They're using the up. This is going to be the up arrow key. This is ASWD. I'm going to be implementing this same thing. And I'm going to put it inside the player because it's about the player moving. So I'm going to put it above the draw. We're going to say function player, and this one's going to be update. And what I want is I'm going to say if is love keyboard. So is down, and I want to check if left is down. That's the left arrow key. So if left is down, then, so what I want to do is I want to move this to the left. I already have X created right here, so it's already available. So I can say self.x. So we're moving to the left, so X needs to be getting smaller. And it's underscore X equals self underscore X minus, let's say 5. Again, we're not going to use this 5. This is just for initially setting it up. So that one, and I'm going to copy this. And I'm going to make it for the right as well. This will get more complicated, but I'm just doing it in steps. So this one will be right. And I'm going to add 5 to it. Whoops. Okay, so that should just move. And we are using X here. So as we change X, when it draws, it'll be there. So we just need to hook up the update into game. So if we go over here into game, and we'll say self.player update. And now in main, we have to hook it up as well because we never, so right here, update. Game, update. Okay, so I'm pressing the right arrow key, and then I'm pressing the left arrow key. And it goes right off the screen because we're not doing anything to check bounds yet. And it goes right off the screen the other way. So back into player. So basically we told main to tell game to update itself. And in game is telling player, which is an object inside a game, to update itself. And anything else that needs to update will be in here now. Everything's going to happen in here in game. So in player, we are updating, we're moving itself, but I don't like this right here. We're moving it by 5 every tick of the game. And the game is ticking over at 60 times a second, or it should be. We don't know if it is or not. So we can do something else. By default, Love2D is putting in delta time, okay, in seconds. So where is it? Do I have delta time opened up here? Love update. So there is a DT that you can add, and this is delta time, and this is keeping track of the time that has changed since the last time through. So if we're ticking over at 60 times a second, this delta time will be 1/60th of a second. So if I'm moving 5 pixels every tick, every time the game ticks over, if I'm moving 5 pixels in 1 second, that will be 60 tick overs that I moved 5 pixels each time. I should be moving at 300 pixels. So 300 pixels in 1 second. Okay, but what happens if I start ticking over at 30 times, if I don't have a constant frame rate? Well, if I'm ticking over at 30 times a second, now I'm only moving 150 pixels. So what I should be doing is moving further each time if my delta time slows down. So the way that you do this is you can multiply, they even have a thing down here. So if I take 300 pixels in 1 second and I times it by 1/60th of a second, I'm actually going to get 5. So that's the speed I'm moving now. But if I was ticking over at 30 times a second, if I take 300 and times it by 1/30th of a second, I'm going to get 10. So each tick it's going to move further, but in 1 second I'm going to move the same distance. So to the player, it's still going to look correct. So I hope that kind of makes sense. So what I want to do is I want to use delta time here. So in main, if I put DT here, it's automatically going to populate that with delta time. That's part of love. It's automatically going to do it. Now in game doesn't know about this. So I'm going to pass it in to game. And in game, I need to be capturing it. And I'm going to pass it in to player. So this is being propagated all the way down. So the player update is now going to have access to delta time. So if I put it here, so now I got it all the way down into this function. Yeah, it's unused. Okay. So what I'm going to do up here is I'm going to create a constant for speed, and I'm going to set it to 300 because that was my target. So I'm going to put it as player speed. And I'm going to fix one side and not the other, and you're going to see that they should be moving the same speed. So player speed, and I'm targeting 300 pixels a second. So I don't care what my frame rate is as long as I'm moving at 300 pixels a second. So what I'm going to do down here is I'll do it on the left, and I will say, because of order of operations, we'll say the multiplication happens first. Player speed, and I'm going to multiply it by delta time. Now remember, delta time is less than 1 because, well, unless your frame rate is really low, but it's dividing, it's in seconds how much time has passed. So it's taking this big number, multiplying it by a number smaller than 1, we're going to end up with a small number. If we're at 60 frames a second, it should be around 5. So dt. So I've fixed one side and not the other, and we should see that the game should be moving about the same for each direction now. So I'm moving left. Oh, I've made a mistake. So dt is nil. Okay. Let's make sure it did get passed all the way through. So did game pass it through? I'm sorry, I put it on draw. Somebody was probably yelling at the screen, "What are you doing?" It's not, it doesn't exist in draw. It does exist in love update. It's automatically there. Okay, so I'm moving right. That's the one that has the fixed time, and I'm moving left, and this is using delta. Okay, they're both kind of the same speed. But this will, using the delta time, will allow it to, if it goes down to 40 or goes up higher, or if it goes down to 30, you're still going to be moving correctly. If you go way low, down to like 10 frames a second, it's going to look choppy, but you'll still be moving the correct speed. So I'm going to fix both of them. Player speed times dt. That gives us moving, but we are not checking to see if we're running into things or not. So I want to be able to check the left and the right. So after I've moved X, or I've updated X, I want to check to see if the left is smaller than 0. I want to see if the left side of my image has gone off the left side of the screen. If it is less than 0, I'm just going to set it to 0. I'm going to create a getter function up here, because I am going to be using left outside of this class. I'm going to be accessing it from outside, so I'm going to be using a getter. Remember, I said I'm never going to access the _x. Even though this is happening inside the class, I'm going to be using this later outside of the class. So I'm going to say function player left. And what I want this to do is to return the left side. And it actually won't even be the left side. We'll change that as well. So the left side is X. And let's do this with the right as well. Now for the right, this is going to be X plus width. So this gives us left and right. And again, the reason why I'm doing this is I'm going to be using these externally later. I'm going to be accessing this information. So internally, I could have just done this, but also there's going to be some math going on, so this simplifies it. So I can say if self colon left is less than 0, and now I just want to set what it'll be. So I'm just going to set it to 0. Okay, so that's going to set it to 0. And I'm going to do the same with this one here, but on the right side. If it's larger than, and I need the screen width, I'm going to say the love.getScreenWidth. It's graphics. So I'm checking the right side. So if the right side of the image is bigger than the right side of the screen, then what am I going to do? Well, I'm going to set self underscore x. Now I need to do a little bit of math because I need the width of the screen and I need to subtract the width of the image so that the image is still on the screen. So I'm going to say love graphics.getWidth, and I'm going to subtract self.width. Okay, so that's going to kind of keep my image on the screen, but it's not going to be correct. We're going to see why in a second here. See, it stops, it's checking the very bottom of the image where the little snow is here. I actually want it to be closer to here, so we're going to make an offset. And over here, it's doing the same thing. So it is working, but I actually don't want to use the image bounds. I want to bring it in closer to the head. Basically, I figured out the offset for the left and the right. I want to bring it in around 47 pixels to have it be closer to the head. So I'm going to create a left and right offset. Left offset equals 47, and right offset 47. So now what I can do with this is the left side isn't the left, it's the left plus the left offset. And the right will be minus the right offset. Okay? But that's going to now check the bounds to basically where the head is. But the problem comes in here where we're actually setting it, we need to take this into account too. So if it does happen, otherwise when it hits, the head hits, it's going to glitch out and move over 47 pixels because the checking's happening around the head, but it's being reset around the body instead of the head. So we need it to happen on both of them. So instead of saying 0 here, I need that left offset. So I'm going to say minus left offset because I want the left side of the image to actually be drawn off the screen 47 pixels. And for this one on the right here, we are going to add the right offset to it. Doesn't really matter where I put it, but I'm going to put right offset minus self width. And that should be getting us a little bit closer. There we go. The head kind of hit the edge of the screen and the head kind of hit the head. Okay. Now I want to know if this image is left or right. So I'm going to create a variable in here, a Boolean. I'm going to call it isRight. And again, it's internal, so I'm going to give it an underscore. Is right. I'm going to set it true because we're starting out on the right. So that's just a Boolean set to true, but we can use it down here to draw to the right or to the left. So I'm going to say if self is right, then, and I'm going to duplicate this. And up at the end here. Let's see if it all fixes itself now. Okay, so basically if it's right or left, I'm drawing the exact same thing right now. Now, I need this Boolean to change. If I'm moving right, I want it to be right. And if I'm moving left, I don't want it to be. So right here, I'm going to set it to self.isRight equals false because we're moving left. And down here, when we're moving right, I'm going to say self.isRight equals true. So that's setting the Boolean, but we're drawing the same thing either way. Now, the problem is when I draw, well, we're going to see what happens here. I'm going to flip the x-axis when it's to the left. So we already had the right one is correct. When it's to the left, I'm taking the scaling of x. Remember, this first one is x, the second one is y, this is the radians. Now this is x scale and this is y scale. So if I just set the x scale to -1, it actually draws backwards. But we're going to see that the image actually moves. So we're going to fix that. Whoops, not here. I want to do it here. Okay. You see how it jumped? What's happening is it's drawing the whole image in reverse, but we also now need to reposition where we're drawing the image. We need to subtract the whole width of the image. Or, sorry, not subtract it. We need to add it. So on this one, when we flip it on the x-axis, we need to actually add the width of the image to it to get it to draw in the same spot. Self_width. I believe that's it. That should fix that. There we go. Now our snowman switches directions, but doesn't jump one way or the other. Okay, so this is our snowman moving back and forth. So this is where we ended off with. Let me just show it one more time. So we've created a player class. We've made an instance of the player class. We let the player class draw itself. Let me just show you in the code here. So these are constants up here. Now they're constants in they're not real constants, but they're convention constants. Just like these are not real private data, it's just a convention. Okay, so I'm using this isRight Boolean to know if I'm facing right or left. Down here, this is the constructor. That's basically just adding in the image table to the new player, and it's getting the dimensions of the image and also centering the X to the center and just returning it. That's just the constructor right there. For left, we are getting the left side of the image, but we have this offset. And for right, we're doing the same thing. We're getting the right, which is the X plus the width, and then minusing the offset to the right side where we want it to be, kind of shrinking the box down there. We're using this keyboard.isDown to see if we're pressing left or right. And this is so you don't get a repeating thing. Like, look down here. If I press the A key, it says A, and then it repeats. We don't want that. So this is not doing that. This is instead just checking is the state down. If the state is down on each tick, so it's not a repeating thing. It's not press A, wait half a second, and then start repeating pressing A. It's not like that at all. It's saying, is the key down? And the key is left and right. So we're using that, and we're just setting that Boolean right away on both of these to be left or right. And then we are using the standard Lua way of taking a variable, and we can't plus equals it or minus equals or whatever. We have to take the variable and we have to make it equal to the variable and the adjusted bit. And we're using this player speed times delta time so that if we have a slower computer, our game is still going to act correctly. Or if you made Lua run faster than 120 or 300 frames a second, the game would still act correctly. You would see the player still move at the correct speed. And then we're checking to see if we've run into the edge of the screen, but we're using the left, that's calculating our offset for us. And we're using the offset to set it if we have gone off. And we're doing the same on the right, except we're checking the width of the screen. And down here, we are drawing it, but if it's right, we're drawing it normal. If it's left, we're drawing it with the X reversed. But because of that, we need to actually add the width so that the image doesn't move on the screen unnaturally. Okay, so this is how to do that. I'm going to save this because I was pricing those A's earlier. In game, we're just requiring the player just to get access to that player class. We're instancing a player with the new method inside a game. We're just calling it player. And now we can tell player to update itself, and we can tell player to draw itself. And we're using this delta time that's passed in all the way from main, because that's really where it's coming from. It's coming from love. We're getting that number that's populated into delta time, and this is happening every frame. And it's going into game, it's going into the game update, and the game update is passing it off to the player update. And we'll pass it off to the flakes as well. So that was everything. In the next one, we will be creating the flakes. We'll have a flake class and a bunch of instances, and we'll have white and yellow flakes. And it'll be really cool. So hope you enjoyed that one, or hope you learned something, and have a good day.